In one of the coldest, driest places on Earth, a glacier is bleeding. Streaking down the white face of Taylor Glacier in Antarctica is a stain the color of dried blood, unmistakable against the surrounding ice. Early explorers who found it in the early 20th century assumed it was caused by red algae growing in the meltwater. That explanation was accepted for decades before anyone tested it properly. The truth turned out to be far stranger than algae and far older than anyone expected. Whatever is producing this color has been sealed away from sunlight, from oxygen, and from the rest of the planet for well over 1 million years. No plant, no visible organism, nothing living on the surface explains what's happening here. And yet, every so often, this crimson liquid still finds its way out. To understand why, researchers had to go looking for something no one had ever confirmed existed beneath Antarctic ice. The investigation began with a question nobody had properly answered. Where was this red liquid actually coming from? Ice-penetrating radar was brought in to look beneath the glacier without drilling a single hole. What the readings revealed surprised even experienced glaciologists standing at the camp. Sealed beneath roughly 400 meters of solid ice was something that shouldn't have been there at all. A body of liquid water, isolated from the surface, sitting far below the freezing point most people associate with water. Samples collected directly from the seep gave researchers their first real chemical clues. The liquid was intensely salty, far saltier than seawater, which explained how it stayed unfrozen at such extreme cold. Iron dissolved in the water was reacting with oxygen the moment it touched open air. That single reaction, iron rusting almost instantly, was the real source of the crimson color everyone had been staring at. Under the microscope, the evidence became impossible to dismiss. The sample wasn't just salty. Iron-rich water, it contained living microorganisms, actively moving within the liquid. These weren't organisms that had simply washed in from the surface at some point in the past. Genetic testing later confirmed they belonged to at least 17 distinct microbial types, all uniquely adapted to total darkness. None of them relied on photosynthesis, since no sunlight had reached this water in well over 1 million years. Instead, they appeared to survive by cycling sulfur and iron compounds trapped in the ancient seawater around them. Multiple seep points along the glacier's base showed the same chemistry, the same reaction, the same underlying source. Salinity readings confirmed the water was roughly twice as salty as normal seawater, low enough in freezing point to stay liquid at extreme cold. Every test pointed to the same conclusion. This wasn't meltwater. It was an ancient, sealed ocean, still alive.
Organisms. Under the microscope, the evidence became impossible to dismiss. The sample wasn't just salty, iron-rich water.
Here's the twist that reframed the entire discovery. This wasn't a small, isolated pocket of trapped water, a curiosity limited to one glacier. Ice core dating and radar mapping suggested the reservoir extends far beyond the visible seep, potentially stretching for miles beneath the surrounding ice sheet. Researchers now believe this water has remained sealed, completely cut off from light and open air, for somewhere between 1 and 5 million years. That places its isolation before the earliest ancestors of modern humans existed. The microbial community living inside it has had that entire span of time to evolve in total darkness, with no outside influence at all. In evolutionary terms, this ecosystem has been running its own separate experiment for longer than our species has walked the planet. What researchers are studying at Blood Falls isn't just a strange colored seep. It's a self-contained pocket of deep time, still chemically and biologically active today. The scientific explanation ties every piece of evidence together into one coherent picture. Millions of years ago, a body of seawater became trapped beneath advancing glacial ice, sealed off completely from the surface. Its extremely high salt content kept it from freezing solid, even as temperatures around it dropped far below zero. Without sunlight, the microbial community trapped inside adapted to survive on chemical energy instead, cycling sulfur and iron dissolved in the ancient water. When that iron-rich water occasionally finds a crack or fissure and reaches the surface, it meets oxygen for the first time in over 1 million years. The reaction is nearly instant. Dissolved iron rusts on contact with air, staining the ice a deep, unmistakable red. None of it requires anything exotic or unexplained. Just an unusual combination of geology, chemistry, and extreme isolation. What makes it remarkable is what it suggests elsewhere, that liquid water sealed beneath ice, entirely without sunlight, can still support life. That's exactly the kind of environment scientists now search for on icy moons like Europa. Researchers now understand where Blood Falls' color comes from, and roughly how long its water has been sealed away. What they still can't fully answer is exactly how large this ancient reservoir truly is, or how many microbial species within it remain completely undiscovered. Every new sample taken from the seep has turned up organisms not previously cataloged anywhere on Earth. The full extent of the reservoir beneath the ice sheet is still being mapped, one radar survey at a time. For now, Blood Falls remains one of the strangest active windows into deep time found anywhere on the planet. A place where an ocean older than humanity itself still quietly seeps into daylight. It offers a working example of exactly the kind of hidden, sunless ocean scientists hope to one day find beneath the ice of a distant moon. Case file #026 is closed. The mystery remains.